You see the countdown?
Yeah, 5
Five,
seconds.
4. Guys, if you haven't had your coffee yet, you might not need it. The energy in the backstage um, is palpable. Rui, am I pronouncing your name right?
Yes, you are. That's perfect,
Okay,
Ro.
we got talking about soccer, football if you're outside the United States, and SQL and analytics engineering, and the Rui's energy is fantastic. So I'm gonna let him take it away. Rui, take the floor.
Thank you. Thank you, Ro. Yes, I mean, unfortunately for the audience, this is only about SQL. We're going to keep soccer out of the agenda for today. But welcome, everyone, and thank you for joining this session. I'm really excited to share my vision on SQL and what I feel it's going to be the future for this language. So I'm going to go ahead and share my screen. Should take just a second. Here we go. And I think it's on stage. So by now you should all be able to see my screen. So once again, welcome to the resiliency of SQL, or as I like to say, why should you care about a data engineer, about this old language, as some people actually call. I don't think it's that old. It has been refreshed, but let's see what you think after this session. Very briefly, just one slide on myself, for the ones that don't know me, in case PowerPoint helps me. There you go. So right now I'm leading data engineering and architecture at the H&M Group. It's the fashion company. Probably many of you actually know very well. I'm also a data and AI advisor for a few organizations, and I'm a co-author of the book Analytics Engineering with SQL and DBT, which was co-authored with my dear friend Elder, which promised to be here today with us. So I think he joined us from the audience. Before joining H&M, I've been leading several data teams in different organizations. I've worked at Jumia, the largest e-commerce company in Africa, Nike in Europe, where I lived in Belgium, and I also worked for Meta. Back then, I was living in London, leading some data engineering organization responsible for malicious interactions, which was a very exciting field. So in all of these different experiences, as you might imagine, SQL was a common denominator. I'm a big fan of SQL, and since I started my career, it has been my dear friend when it comes to hands-on work. So let's go ahead and kick off this session by opening up a very fancy yet simple SQL query here, right? So I believe that just like many of you, I started back in the days where this was called business intelligence. Data engineering was not a concept back then. It was not yet defined. So BI was exactly what we were all doing. And most of the BI work was actually done around SQL. The query that you see here on my screen was a very typical one, right? These were the golden days of simplified queries. We only had to worry about incremental loads in our ETL processes. We had to select the fields that we needed for running our analysis downstream. And of course, we had to apply some filters. Some of you might say that there were more complex ones. Yes, there were. We had to apply business rules. But in general, this was what a SQL query would look like. So 15 years ago, it was not really about if you were using SQL or not. It was more about what engine were you using. You would be using SQL Server, Oracle, MySQL, or Postgres. But the truth is, you were most likely using SQL back in these days. However, SQL has evolved a lot, right? And these days you find SQL everywhere. It's not just about relational databases. Right here on the screen, you can see an example of a very simple DBT model there. And you can see that it's not just about the SQL syntax anymore, right? It's also about the macros that we use. It's also about the configurations that you want to be used when you are running your SQL queries. And it's also about the platform that you are actually running SQL on. Again, it's no longer just about relational databases. It's about much more. And this is what I'm going to take you through today. So we're going to go through the whole data management lifecycle, and we're going to see where SQL is being applied. At the same time, we're also going to look at some fantastic advancements made from Google, because they are coming up with the new SQL syntax. It's called Google SQL, and they are turning some things upside down. So I want you to be aware of these latest advances in the SQL syntax and what Google has to show us when it comes to this. Again, these two slides were just to show you that SQL didn't have a linear evolution. And I think this is completely normal. I mean, there is a guy that has a very simple sentence that says, things don't always happen the way we think they will, but they kind of happen exactly the way they should, right? And this is really interesting when we look at the history of SQL. I promise this is not going to be boring. Just one simple slide on a little bit of history about SQL. SQL is actually quite old. Back in the 60s, a guy called Edward Codd came up with a relational model. In the 70s, two scientists came together, Don Chamberlain and Raymond Boyce, and they created the first SQL language. So this was based on the relational model of Mr. Edgar Codd, but this was the first time that we actually had a language to run against a certain engine. But it was only in '86 when this actually became a standard, right? And the SQL that we all know, called ANSI SQL, became a thing across many organizations. And this is when Oracle, IBM, Microsoft started adopting this language here. Now, this is, again, a common story. I believe many of you know this. What I think most of you don't really know is that when Don Chamberlain actually designed the language, this was not designed to be used by computer engineers. They were actually targeting for, those casual users, the business users, people that were looking for something very simple to be used to get data from a certain system, right? So it's quite interesting, and it's another instance of things don't always evolve the way we think they will, because again, Don was not expecting that all of us, computer scientists, engineers, data scientists, would be using this language, 50 years later. So it's quite exciting, when we look at the history and compare with what happened, the growth of SQL over time. But let's just zoom in a little bit into the three simple concepts that Don Chamberlain had in his mind when he was designing SQL. So first, they wanted to write something that was non-procedural. So they wanted a language where you could focus on the what instead of the how. I mean, when many of you open VS Code or any other IDE and you start writing in Python or in Java, you're basically writing how you want your algorithm to be executed in runtime, right? When you are running a query against the SQL engine, you're basically telling him, what do I want to get from this database? So this was one of the dimensions of the language. And the last two are also very well known. They wanted to create something that was readable. And that's why they were targeting the casual users, because these were the people that couldn't program in the complex languages of the time. And they wanted a simple interface. So you have a database engine, you connect to this, and you start running queries, right? And let's be honest, I think they had a point. I mean, here on my screen, on the left, you can see a little bit of PySpark. And on the right, you can see the equivalent code in SQL. Many of you might actually believe or might actually think that the code on the left is easier to read than the one on the right. It's not really my point, right? My opinion, actually, I think it's actually quite easier to read the code on the right side. It's more closer to the natural language. It's quite interesting when we say natural language, right? Because we're living in the Gen AI world where people are now writing in English to get stuff from a certain system. But again, I think SQL lives in between, right? It's close enough to the English language to make it simple to read and simple to write. I'm not saying the ones on the left don't have its merit, because again, there is a certain engine behind. But the truth is, you can write Spark in SQL as well, and then everything gets converted to Spark jobs. So, this is just an example of how SQL can make your life easier. It's easier to read, it's easy to write, and it's declarative. So you can really specify what you want to get. This actually gets us to the first checkpoint of this presentation. And many people think that SQL has been a static language over time. Many people think that the SQL code they were writing in SQL Server, 15 years ago is exactly the same as of today. This is not true, because SQL has been evolving itself. if you look at the several standards that have been issued over time, and if you compare the standard from 86 to the one in 2003, you will see that lots of things were added over time. Some of these things super exciting for data engineers. For example, it was only in 99 that recursive common table expressions were introduced. We're going to zoom in and deep dive into this one. But in this slide, you can see that SQL has been trying to adapt, to the evolution of times. The systems have been changing. There was a huge transition from legacy on-premises systems to the cloud. So lots of different things happened in the tech world, and SQL has been trying to survive. And that's why I often mention the resiliency of SQL. It's like a cockroach. It's super resistant, but at the same time, it's not static, waiting for another time where it will be relevant. No, it has been evolving over time. And again, I promised you that we were going to zoom in to some of these additions in the syntax that happened over time. And I want to start by highlighting one of them. So before 99, and I was from this time, maybe many of you were from this time as well, nested queries were king when it comes to building complex queries, right? By nested queries, I mean using the output of a certain query as the input for an outer query that you're writing in the same script. So here you have a very simple example where in the from clause, I'm actually consuming the output of the select statement that I have inside. Now, this example that I have here on my screen is actually quite simple to understand, but I don't need to say this a lot of times during this interview. I'm sure many of you are going to feel the pain. This can actually grow, this type of designing queries can grow into thousands of lines of code full of nested queries that no one really understands. And when someone says, hey, there is a data quality issue in this query, it's a nightmare for us. We need to start cut and pasting the inner queries into another tab, evaluating it and making sure there is no errors, and then putting it back in the master query. This is really, really complex to manage after a while, right? So in 99, the ANSI, the American National Standards Institute, actually introduced common table expressions. And again, there are some people that argue that CTEs have a slightly different performance to nested queries. I'm not going to challenge performance here. I'm just focusing on readability. The truth is, CTEs make the code very, very much more readable, right? You can actually create specific prefix queries that actually solve specific queries that you want to run, and then you can use them in a final query. So here in the screen, I'm sure many of you are using common table expressions, but I think for data engineers, this is actually mandatory because there are platforms, we'll get there, like dbt, that actually assume that you're going to write your code with CTEs. Again, for me, using CTEs was a game changer. I still remember the day a friend of mine came and said, well, have you ever tried using CTEs? And I felt, nope, I'm not going to go this road. It sounds like a very complex definitions, common table expressions, but it's actually quite simple. So it's just another way of structuring your code in a pipeline-like format, right? So you start building the smaller structures that you need, and then you use them in the final query. So this is one big evolution of SQL that, again, made it very relevant today, and we use common table expressions when we use dbt, for example. Another great addition to the SQL syntax is actually related to group bys. So group bys are still very relevant today. I'm not going to argue this. We all use group bys on a daily basis. But the truth is, when group bys popped up, and this was part of the initial definition, they were actually used to build aggregations, but in a way that it would collapse multiple rows into one single solution row. Right? So you have there a simple image on the bottom right that shows what happens when you run a group by, right? You define the group by clauses, but the goal is to actually flatten the structure into a simplified row that contains your aggregations. Now, there are cases, for example, within the statistics world or the mathematical world, where we want to use the result of a certain aggregation at the row level, for example, to calculate ratios, right? So SQL actually introduced another great addition to its syntax, which is called window functions. many people, and this still happens in 2024, many people are still very afraid of window functions. They can be super complex, that's true, but window functions are a great addition to calculations and to aggregations in your structures when you want to have access to these aggregations at the row level. For some people, window functions and for certain use cases can actually achieve a much better performance than group bys. In some cases, it can be used for the same use cases with, again, great advantages from a performance point of view. But once again, we have a great example that I believe it's actually mandatory for data analysts and data engineers to fully own, because it can solve very complex use cases in a simple manner. For example, imagine that you're calculating the salaries of people in your organization, and at the row level, you want to know who's the person that earns, the more right after the one that you're analyzing in the current row, right? So you can do this with window functions without affecting the granularity of your structures. You need to be careful with window functions. Again, they can be more or less complex depending on the use cases, and not everything can be solved with window functions. But it's another great example on how SQL has survived over time and has adapted to the needs of analysts in this case, right? So again, just two examples that popped up in the standard until 2003, but SQL didn't stop there, right? SQL continued evolving. It introduced JSON handling functions, date and time formatting and parsing. I'm sure many of you have been using, much more complex functions and operators in SQL. But there is one last thing that I want to highlight from a history point of view that many people actually don't know. But the same people that have been working on the standards for SQL, the ones working in ANSI and then the ISO standards for SQL, were actually part of a new standard that popped up in 2024, which is the GraphQL. It's called GraphQL 2024. And actually, this is being called a sibling standard to the SQL one. And for me, this is a very strong message to the industry. It's basically the proof that graph structures and GraphQL has been growing dramatically in the last few years, and the demand for standardizing this language has actually increased. So you can now actually have access to GraphQL. You can Google it. It's already available. Many vendors haven't yet adopted some of the recommendations of the standard. But the cool thing is that SQL has actually been inheriting some of the advances on GraphQL and vice versa. So again, this is a strong message to all data engineers out there. If you haven't really learned about graph structures, about graph databases, take some time. If I had to suggest something for you to learn about, it's definitely graph structures. It's everywhere. Even when you're building semantic layers, try to look at graph-like semantic layers. It's all over the place these days. So it's definitely a great thing to learn about. It's just a curiosity. It's not SQL, but I still think it's relevant to mention. And by the way, this player that you see here on the screen, it's a Swedish player that plays for my club, which is Sporting Lisbon. For the ones that don't know it, you can Google about it. But just a fun fact about that player over there, in case you're curious. Now, moving into more exciting fields, and now we're going to leave the history behind, and now we're going to start focusing on today. So why is SQL still relevant today, and is SQL the perfect language for all the analysts out there? Google has actually rushed into researching about the SQL syntax and really trying to understand what are the pros and cons of this language. And they came up with some very, very interesting conclusions. And the first one is something that I have been complaining for a very, very long time. For example, the clause order. If you think about it, 15 years ago, when you were running SQL against relational databases, normally you had one database behind it, right? But these days, you have very complex structures. We live in the big data world. So sometimes, or most of the times, you're getting data from multiple tables, right? You're trying to combine all of this. So before you actually think about the attributes that you want to analyze, you need to sort out where you're going to get this data from. And so Google has been challenging the clause order. They say, instead of starting with select, so select from, maybe we should be allowed to actually start with the from. So you start with from, you define the tables you're going to get the data from, and then you move to the select statement, and you select the attributes that you want. At the same time, what we have been seeing is that, SQL has a few redundant clauses. I know they're different. Many of you are going to argue and they're going to say, okay, but the where and the having are different. I know it is. So where is for data sets, filtering data sets. The having is for filtering group sets, so after group bys. But the truth is, they all fit the same purpose. The purpose is to filter data, right? So Google has been arguing that these are completely redundant clauses and that maybe we don't need all of these. Maybe we can use just one and avoid the complexity of needing to know that we're handling a data set or a group set. Last but not least, SQL forces us, because of the nested queries, and even if you use common table expressions, to think your queries in an inside-out perspective. So if you think about a nested structure, the most granular structures are always inside your nested query. So you always need to think from the most granular, feed the output to the other query, and so on and so forth. So you're thinking from inside out. And this is not a very exciting perspective when you're handling complex data, right? Because it forces you to think in a linear way, and some data structures require you to think a little bit different. So let's look at what Google is actually suggesting as the next evolution for the SQL syntax. And by the way, this is already available, for example, in BigQuery. So if any of you guys is using Google BigQuery, it's already compatible right there. And Google is calling it the Google SQL. They have published an article in case anyone is interested. It's right there on this slide. But basically, if we look at the solution that Google is suggesting, they basically want us to completely break down the clauses of SQL. So instead of having to combine them in a sequence way, they want us to think them independently. I know that conceptually speaking, this might be a little bit hard to understand, but let me give you an example. Let's imagine that we want to run a very simple analysis for a certain order. So you have orders and you have order line items, for example. So you actually set first the from. So you say, I want to query something on this table structure. And then you can see that there's a new operator there, which is called extend. Because what Google is arguing is that in most cases, analytics cases, you end up creating new columns, synthetic columns that fit your analysis, right? So instead of having to use them in the select statement, Google suggests that you just extend the original table, and these columns will be virtually created for you. And you can actually access them, further in your analysis. So it's not just a static one that lives in the query. It actually stays virtually in your structure. Sorry. So you can see here what Google is suggesting, which is a pipelining structure. Let me just have a little bit of coffee. It's always needed. But again, this is not massified yet, but it's just Google's perspective on how we can simplify this inside-out perspective and how can we think our SQL queries in a completely different way. I mean, the reality is that Google SQL is growing a lot. So Google has been seeing a lot of adoption by the users inside the GCP ecosystem, and they are considering expanding the availability of Google SQL to more services inside their offering. And at the same time, they also think the industry could benefit from this addition or this change in the SQL syntax. So this is what I have for you in terms of how Google perceives this thing. Now, let's do an exercise together, right? I want to prove to you that you can actually use SQL alone just to build a whole or an entire data management flow. So I want you to look at ingestion. I want you to look at storage. I want you to look at consumption. And basically, I want us to really look at the whole process and see how SQL can actually help you building systems in there. And for me, this is the biggest proof of Google's or SQL, resiliency. And I picked up a sentence from Charles Darwin, which talks about the survival of the fittest, right? And he says that we need to adapt in order to survive or to succeed. And now I'm going to show you that SQL has been doing exactly that. So I want to start by making an agreement with all of you, which is, let's imagine for a second that this is a data management lifecycle. This is the simplest of the data management lifecycles, right? So you ingest data, you model and transform, you store, and you consume. And now I'm going to show you how SQL stopped being just an interface for relational databases, but it's now some sort of a parasite that exists in many platforms. It became really just an interface to basically execute operations on platforms. And I'm going to show you can do this again across the whole management lifecycle. First, and I don't think this is a surprise for you, let's start with ingest. When I started my career, most of the ETL processes were batch based. Then came CAP architectures, Lambda architectures, real-time became a thing. OLTP systems became or were completely refactored to include Kafka. And so Kafka became a thing. I also still remember when I was really afraid that basically I had the fear of missing out, of not understanding Kafka. And then one day I was doing my research and I discovered this. I discovered that Kafka actually had an interface, some sort of a platform that, by the way, these days no one really knows if it's dead, if it's gonna die. KSQLDB, it's still out there. I know it's being used in some projects, but the purpose here is not, again, to show the most relevant platform, is just to show an instance of SQL reinventing itself. And so KSQLDB is a pure SQL interface that allows you to interact with Kafka in every single way you can imagine. For example, it allows you to create connectors to certain JDBC data sources. So as you can see here, just like you create tables in SQL, you can actually create sources. So you write something like create source connector riders, and then you specify the properties to connect to that specific source system, right? Right next, imagine you have connected to this specific JDBC system. One
Hey,
can
Rui,
actually build row. Yes.
So I lost track of time. We've got 3 minutes before the session is supposed to end. Technically we can go longer, but we want to be respectful if people need to go to another session. Do you just want to keep going? I can actually keep going. You can keep going.
I will keep going. I have great examples to show to everyone, but I promise I can be fast. 5 more minutes and I should be done. It's just really to show some instances.
Yeah, don't.
Yes,
I think you're good. Like, take your time. I think we've got time. If people want to leave, feel free to leave. I mean, it's the internet. There weren't any questions. Your presentation is captivating. Yes, we can all agree. You're an amazing presenter. There was one question, but it was mine. People are saying that they're going to stick around. I want to stick around. I want to hear it. So we're just going to keep going.
Yep. I'll keep going.
And if someone gets in trouble, I volunteer as tribute. I'll let Ben can, tell me, Ro, don't do that again. But I'm going to come off. I'm going to mute myself and you just keep going.
I'll just keep going. As long as I have people here, I won't stop. I will keep sharing my passion for SQL for as long as I can. But I promise you, I mean, it should be 5 minutes. It's just to really show you some examples on how SQL has been surviving. Again, this is a great example of something that a couple of years ago you can only do in Java or in Python, which is actually creating a stream in Kafka. Right? So this is a great example on how you can write SQL, a simple SQL code, to get events from a certain topic. I'm not sure if you guys can actually understand what's going on in this SQL query, if we can call it like this. But when we state from geo events, this is actually a topic in Kafka. So we are consuming events from a topic, we are applying a certain transformation, and then we have a very special clause, which is emit changes. And this is publishing to a new topic, which is supposed to be locations. So again, this is an amazing example for me on how SQL has reinvented itself. And instead of living in a relational database, it actually lives in a Kafka server. And this for me, it's really, really exciting. I've used KSQLDB in a project, and it really simplified the adoption. Again, I don't know what's going to happen with the project, but I hope it survives and we have more people driving this initiative. I had another example for you because you can build topics, but you can also create tables in the Kafka structures. They're a little bit more static than the streams, but again, it's another addition there. And then last but not least, we can actually query certain rows in our Kafka topics. So you can see here how KSQLDB actually offers this possibility. So if any of you don't have any experience with Kafka, you can literally use Docker, instantiate a new Kafka cluster locally in your machine. You install KSQLDB, another Docker container there, And then you can start playing with SQL to actually try out a Kafka on Kafka application. And this, for me, it's actually amazing because it enables people to access certain platforms, even when they don't know, the native languages like Java or Python. Next, and there was a special effect. I didn't know this, but I had this effect. Sorry for this one. Second step in our life cycle is model and transform. And of course, I had to bring this up. I wrote a book on this because I'm a huge fan of DBT. DBT is a SQL platform that exists to model data. So again, it's not an ETL platform, but it's a T, right? It allows you to model your data with concepts like modularity, reusability. It offers a little bit of data governance with lineage and data quality. So if anyone here actually haven't deep dived into DBT, I really encourage you guys to take a look. Even if you're using Airflow, for example, for your ETL processes, you can actually call DBT models, which are entirely written in SQL, inside Airflow. So it's a great way to manage business rules in the SQL way and model your data in a SQL way, but still, for example, having Airflow to orchestrate your ETL pipelines or Google Cloud Run or anything else. Again, DBT offers a lot more, but I brought an example for you on how DBT is amazing and what kind of syntax additions they bring. So you can see here in black that DBT has this concept of source. And what source is actually a model, which imagine is a script, is a SQL script that's stored somewhere else. And you can call this script in here. So it's actually amazing for collaborative SQL work, which has always been a pain for us working with SQL. It's not easy to have two people working on the same query. With DBT, you can actually create a model and then share with the whole organization. And if someone wants to combine your model with something else, they can just simply call the macro source to call your script that lives somewhere else. So again, if you guys haven't heard about DBT, please save some time and take a look at this. Then we have store. And I'm going to go a little bit faster on this one. But for the ones that actually have never heard about open file formats, I'm going to just name them out, the three most famous ones, Apache Iceberg, Delta, and Hudi. So for a very long period of time, whenever we were using blob storages to store our data, like Amazon S3 or Google GCS, the cloud storage, we were often using Parquet, right, which offered high compression. It's a very efficient way of storing our data. However, some people started realizing that Parquet was not offering some of the advantages of the old data warehousing systems, right? And because the data was living there, it would be highly beneficial to have this interface right there. So some organizations started building this, and then concepts like Lakehouse, I'm not going to deep dive, we could spend a whole session on this, but they actually came up with these new file formats, which are based on Parquet in most of the times, or Avro, and they allow you to do a lot of things. They allow you to time travel your data. I have an example to show you. They allow hidden partitioning so that you don't need to worry about this. They allow full scheme evolution. So it's really, really, and ACID transactions, by the way. It's really a great addition to Parquet, and it's a much more efficient and analytics-oriented approach to store data and offer an interface to consume this data. And I don't think I'm going to surprise you. These open file formats offer what? A SQL interface, once again. So look at this simple query that I have here on my screen. This is amazing, and it would be the dream a couple of years ago. You can actually query a certain structure that's stored on, for example, Amazon S3, and then you can specify for timestamp, as of timestamp, blah, blah, blah. What this means is, although the data has been refreshed on a daily basis, you can actually look at the data as it was, for example, 1 month ago. And this is amazing for comparison of historical data with current data. If you have a data quality issue, you can easily spot that. You can roll back your data if you need to, if there's a major issue in terms of data quality. So again, open table formats actually offer this SQL-like interface with amazing additions to the syntax. So once again, it's SQL reinventing itself. Now, last but not least, I'm going to talk about consumption. So we have ingested data with SQL, with Kafka. We have modeled the data with DBT and transformed it with DBT as well. And we have stored the data in Apache Iceberg in one of the blob storages available out there. Most of this work with SQL. I'm not going to say 100%, but most of this, right? Now, let's talk about consumption. And I want to bring one platform which actually revolutionized the project that I was involved in a couple of years ago, which is called DuckDB. Not a couple of years, it was 1.5 years ago, actually, because I was using Pandas to process my data, right? But Pandas is single-threaded, so it was not giving me the performance that I wanted to have. At the same time, it's Python. I'm Pythonic, but I love SQL, as I mentioned before. And then I discovered DuckDB. So DuckDB is an amazing in-app or in-app database. So if you're running Python, for example, you can easily instantiate a DuckDB database. Simply do pip install DuckDB, and then suddenly you can start using DuckDB to process data. And again, no surprise, DuckDB uses SQL as an interface, and it comes with an amazing feature. You can alternate between Pandas data frames and DuckDB in the way that you want. This means that you can load data with Pandas. So you can do from dict, you can do from CSV, for example, and then you can simply do duckdb.sql and literally run SQL code on top of your Pandas data frame. So DuckDB accesses your memory and it knows that there's a certain data frame available for you, right? So this is amazing for people that want to use Python to process their data, but then they want to have access to an amazing engine that can process your data much faster than Pandas. By the way, DuckDB uses a parallelizable engine, and DuckDB also benefits from a columnar engine as well. So it's very well fitted for analytical purposes. Instead of being row level, it's actually column level. So again, you can start with Pandas, you can move to DuckDB to run your business rules in SQL, and then at the end, you can do results.df. And again, it's converted back to data frame. So imagine that you have a huge Python script full of Pandas. You can actually add DuckDB, so you can add your SQL layer in the middle without affecting the execution of your script. You don't change anything upstream, you don't change anything downstream. You're still reading from Pandas, publishing in Pandas, but in the middle you have SQL. And again, for me, this is amazing. Now, for this session, I have prepared a bonus section for this presentation. And for the ones that don't believe that you can do machine learning in SQL, I'm going to prove to you that you can. And for those data engineers that say, hey, I don't know Python, I don't know Java, I don't know Scala, I don't know the Spark library, so I don't really know how I can get into machine learning. If you know SQL, I'm going to prove you that you can. And this is via Google BigQuery. By the way, I've never worked for Google. Google is not giving me anything for mentioning them so many times in this presentation, but I just think they're doing an amazing job promoting SQL and trying to bring SQL back to their core engines. So for the ones that are using BigQuery, which is a scalable data warehouse, a cloud data warehouse service from Google, they have added great clauses in their SQL syntax so that you can do things like create a new model. So the same way you would do this in machine learning, in Python, sorry, with scikit-learn, you can now use clauses like create model, you give it a name, and then you can define options, which for people that are into machine learning, these are the hyperparameters that you often define when you're training machine learning models, right? So you have access to model types, iterations, so you can do all sorts of things in this specific clause in Google SQL available in BigQuery. So in this case, so in this slide, what I'm doing is basically I'm actually creating a new model. I'm training a model with certain data that I have available for me in a table in BigQuery. So if you have data already sitting in BigQuery, you can start doing machine learning, leveraging this amazing syntax edition. And when you run this piece of query, you have access to, training metrics, just like data scientists have. You can see the learning rate, you can see the duration, you can see the loss ratio as well. So this is a new addition to BigQuery. So a new tab will pop up and you can see all these metrics. So what happens after you train a model? Well, basically you want to evaluate this model. You want to use test data. And now Google also offers you a new function, which is called ml.evaluate. And you can evaluate your machine learning model in SQL once again. So you can see that I'm calling the previously created model together with the testing data, right? And when you run this, you have access to a new tab. And you can see here in the new tab, the most famous evaluation metrics that data scientists keep talking about: precision, recall, accuracy, the F1 score, the log ROS. You have the area under the curve as well. So you have everything that you need to really understand if your model was properly trained. And if not, you can retrain and do it again, all in SQL once again. So we've created a model, we have evaluated, we trusted. So what are we going to do next? Predictions. So Google also offers in SQL a new function called ml.predict. So you can actually query a new set of data. Basically, you define the model that you want to use, and you define the table where you want to run the model against, and using which attributes, which should correspond again to the dependent attributes existing in your previously trained model. And when you run this, again, new tab pops up. You have access to, for every single row in the predictions data set that you have submitted, the predictions that were created and the probability of that being correct. So once again, this for me, it's amazing. We have literally created a model, trained the model, evaluated, and made predictions without having to use anything else but SQL. And this was all SQL, trust me. So I think this is, again, another amazing example on how SQL has been reinventing itself. And I'm going to share some news with you. Google is investing heavily on bringing Gen AI capabilities to their Google SQL as well. So I think you can already see some LLM functions in Google BigQuery, but this is going to grow a lot in 2025. So Google is preparing a couple of things for us. So once again, SQL lovers, you don't need to move away from SQL. If you want to be into machine learning, into Gen AI, and again, data engineers, please don't tell again that you don't have the skills to get into machine learning. Now I've just proved to you that you can if you know SQL, right? So I kept outside of this conversation the big powerhouses, right? Like Snowflake, Databricks. They are doing an amazing job promoting SQL, of course. Snowflake is doing, again, a lot of improvements in the syntax. They're also offering real-time additions in SQL. Google BigQuery just introduced continuous queries. So you can do real-time queries in BigQuery as well. So again, all of these guys are doing an amazing job to promote. Guys, this was it for you, but I don't want to leave you before sharing something very interesting. So I actually went to ChatGPT and asked it, how do you think SQL is going to be in 2224, so in 200 years? And this is the picture that I got. I don't know why. ChatGPT believes we're all going to be praying to SQL. But this popped up something in my mind. I was thinking, where did ChatGPT get this from? And of course, it's from Power Rangers. It's exactly the same. It's really a coincidence, but this really happened. So quite funny. I think this guy it was not Megazord. I don't remember the name of the guy in there, but this was nice. So for all of you, thank you very much for staying. I saw that no one dropped the session. So thank you for staying there with me. And I hope that I have shared some of the passion for SQL and I have more evangelists out there right now. So thank you very much. And Ro, I can see you're back.
This is awesome. Yeah, no, there's a very spirited conversation in the chat. Not usually spirited is a euphemism for people fighting, but no, you've got a lot of kindred spirits in the room. I can tell. I wish we could like open the floor and just have like a conversation. There weren't questions, so if you have a question, I had a question, but it was really in the weeds, and it was like super long ago, and I don't even it doesn't matter. I can figure it out on my own. I was just curious. How can people connect with you? LinkedIn? What's like the best way to if people want to connect, or if they want to get the slides?
Yeah, of course. I mean, definitely LinkedIn. So I'm very responsive. I haven't been publishing much, but I'm active on LinkedIn. So you guys can search for me. I have the lion after my name. So this way, I think you will quickly find me. But I think that's the easiest way. So I can also share with everyone. It's RP and then my last name you can see there on LinkedIn.
That's super cool. Well, thanks everyone for staying. Rui, thank you. And that's it. All right. Talk to y'all later.
Thank you. Thanks, everyone.